Hello again. So, second part of the introduction. Well, let's have a look at, first of all, the outline for the course. Excuse me, I'm looking at the wrong thing. Hello again. Welcome to the second part of the introduction. We'll start off by looking at unit outline for this semester. So the prerequisites are all given over here. You can read those things yourself. As far as the resource materials are concerned, you have a unit reader that you can purchase from the UniPrint. That's on-demand printing, so place an order and pick a hard copy for yourself. That contains this outline here, plus all the lecture slides and the problem book as well. It says a flip mode here, but it doesn't make much difference for the moment because essentially all the lectures are online anyway. So all the lectures will appear online, usually the week before, and the workshops are face-to-face for 1 hour and a Zoom session for the second hour. So each of you should actually have a face-to-face session as well as a Zoom session with your tutor. All workshops begin in week 1, which is next week essentially, or this week I suppose, week 1 of semester. They'll all start there. As I was saying in the last lecture, the material actually moves quite fast and it's really easy to fall behind. Please keep up to date. That's the best thing you can do, is stay up to date with material, seek help when you need it, and solve all the problems. So I'll skip the outcomes here, but basically you can read this yourself. The course content is what I'm after here. The basic outline essentially here, as far as what the unit contains, is going to be using maths to solve problems in science. And we'll look at some of the applications as we go through. The issue is that to actually have real applications in science requires a much higher level of mathematics than what we're doing. This is very introductory mathematics, so we can't look at the really detailed and difficult problems in science, but we'll see some of those things as we go through here. So please look at all those yourself. The content is here, and you'll have a lecture by lecture outline of what's going to be happening here week by week. The first week may seem a bit heavy, but most of the things you'll know from before, I'm presuming, so we'll be able to move through this a little faster. But there's time there. The recorded lectures are great in one sense. You can pause them, you can stop them, and you can rewind them. You can look at them again and understand things as you go through. Then attack problems and then seek help from your tutors in the workshops and online as well. So look at those, please. Assessments, they are, I've changed this and I haven't, what you'll find is in the outline here, you've got short tests 1, 2, 3, mid-semester, and short tests 4 and 5. So I need to change this, and I've updated this online, but I haven't quite done it here yet. There'll be 5 short tests at 5% each. That makes 25% there for the short test. There's a mid-sem at 20%. So that makes 45% of the assessment in semester, and then you have the final exam is worth 55%. So please make sure that you look at the updated version. I think by the time this went also to the hard copy, this also was not quite updated, but the earlier version that you see here on the outline has 5 short tests and a mid-semester, and we'll stick with those. So all the tests are every second week of semester on Tuesday. The times are essentially 9 to 10 or 9 to 11 depending, because the mid-semester is longer, it'll take more time. Otherwise 9 to 10 essentially. Most of the tests are half an hour long. I'll get to the details afterwards. If you can't see the test for some reason, please make sure you let me know beforehand, because there is no alternative seatings. If you can't see the test, then you're required to apply for special approval and I'll exempt you. but I wouldn't make that a habit, because the more marks you collect in a semester, the easier it gets to do a good to pass and get a good grade, because the semester assessments are piece by piece in small blocks. All that's assessed to start off with, and you'll find what happens is, whatever I test in the short tests and the mid-semester, I will then not re-examine directly in the final exam. So the final exam then contains only about the last 7 weeks of work. So that really makes your work easier in one sense. You learn things in blocks and chunks, you examine in blocks and chunks, and the last half you get examined separately. It's not the full course you examined on in the final exam. Here are the times for the tests. 1, 2, 3. Again, this is only says 4 here, but I will update this. So there'll be 5 short tests in a semester, and this here is up till test 4, so the test 5 will be in the last week of semester. The exam is going to be 55%, as I was saying here. Please look at all policies of the university. In particular, you're required, the calculators are allowed in this unit, but you're required to have an approved calculator from the approved calculator list. Check that, please. And you need to come to the university, one of the student offices, faculty student office, and have a sticker placed on your calculator that says approved calculator. So you need all those done beforehand, before the assessment starts. All right, so please look at this carefully yourself, and you can keep this document for further reference afterwards. So today we'll do some fun things to start off with. I was saying earlier about simple solutions to complex problems. The issue is, problems usually have simple solutions, but we don't think of them the right way. So here's an example. We all know arithmetic. We can multiply, add, divide, and subtract. And so by using just those 4 operations, addition, subtraction, multiplication, and division, we're going to make 24 using these numbers here I've listed. So 3, 3, 3, 3. You can use each number exactly once. So each number must be used exactly once. You can bracket if you wish to set the precedence for calculations, but no powers, nothing else, only those are all that's required. So the first one isn't so difficult. You can pause this here if you want to have a go at the first one yourself and work it out yourself before you look at the answer. But it really isn't very hard at all, because essentially I'm going to get 24 from here by 3 times 3 times 3. So 3 times 3 times 3, that's 27 and minus 3. So I've used multiplication and subtraction. I didn't require division here, or so multiplication or addition. So it's 3 times 3 is 9 times 3 is 27. 27 minus 3 is 24. So that equals 24. That wasn't so bad. So again, as I say, you can pause the video here to look at these and work some of these yourself. I'll look at the next one as well. So 3, 3, 4, 4. Again, pause if you wish. Have a think about this. So again, this isn't so bad. So it's 3 times 4 plus 3 times 4. So essentially that's 12 plus 12 gives me 24. Now the amazing thing is, I can still do the same. I can still make 24 from this if I change the last numbers. 3355, 3366, and so on and so forth. I want you to try these yourself. Once you've done that, you can check the answers with me at some other stage. So we'll go through this together sometimes in the workshop. But have a look at these. This will actually, essentially, you know all the ideas. You can add, divide, multiply, subtract, all those 4 operations of arithmetic. But you need to think of this in the right way to get the solution worked out. So likewise here, many problems in science, in life for that matter, actually are simple to solve if you think of them the right way. In here, of course, you can use a calculator if you wish, but the calculator is of no use unless the ideas are right. And that's the whole thing here. Mathematics is not about calculations, it's about ideas. And the ideas have to be understood before calculators or computers are used. In fact, we didn't have these calculators or massive computers 30, 40, 50 years ago, and all the big mathematics was done way before that. So in particular, for example, how do you find the area of a circle? Well, the one way to do find the area of a circle is to throw a grid on the circle. So here's a circle. I'll throw some kind of grid over here, and I count the squares, and where they aren't full squares or whatever, I approximate them in some way. I can get the area of a circle like that for every circle. But the problem is, if I do it like that, I never get a formula for this. I never get something simple out of this. And more than that, we never have this concept of the number pi, and the number pi is central in mathematics and science. It's such an important number. We never discovered that. So the important concepts in the world around us can't all be calculator-based, machine-based. They need to be understood as concepts you can generalize from there. And that's what maths is all about, solving things in such a way that become in some generic way, some basic way, and then generalize from there to other problems that look different but essentially are the same. So this is about concepts, not about just calculations or numbers. And the concepts aren't that difficult. This is, after all, an introductory level course for you. It can't be that difficult. And most things we'll cover here, you can use simple numbers over here. Except for some calculations in probability and trigonometry we'll cover, everything else you'll find the numbers are very simple. And in many cases you'll find problems will say to express the answer in exact form. That means something like 7 over 2 or 7 over 8, not the decimal equivalent of this. Or root 3, for example, root 4, is 2, root 3, root 7. Those are exact numbers. We don't want those to be simplified any further or to worked out using a calculator. So as I said, be ready to be out of your comfort zone, because when I start coming to the workshop, I'll throw some curly ones at you, will make you think a bit harder, will be confronting sometimes, but the whole point is life is confronting. Your job afterwards you finish will be confronting. So you need to handle those kinds of things. Mathematics certainly won't harm you, but it'll serve you very well. So all the document things we have there. I want to look at one more thing before we finish this class, and that is to look at the LMS, the Learning Management System, the Blackboard for this unit. You'll find in there are several folders on the left hand side, the lectures, and they'll be week by week like this. You'll have in there listed all the lectures and the recordings as well. There's a problem set as well. That'll contain the problem booklet and the solutions in time. There's an outline there that you've seen earlier. Nothing else here is going to be at all important to you. The only other thing that will be important will be something to do with assessment, and I'll put the assessments in there afterwards. You'll also have past exams and tests here to look at as well. They'll appear also on the left hand side here, so you'll find a little folder appearing there saying past exams and past tests with solutions, so you can look through those and work through those for practice. Okay, thank you. See you again. Bye.